All right, so let's look at a system of equations. What's the only way we know how to solve a system so far of two equations?
Oh.
So there's methods, just like to solve parabolas, to solve parabolic equations, you can factor or use the quadratic formula, and there's other ways. Graph, yeah, so that's what we did. So we're going to graph this guy by hand first, and then since it's really hard to do this exactly by hand, today you guys, I've got the rulers if you need to use them. You do need to use them. That'll help you be more precise, but use your calculator as well to check your work, okay? It doesn't take long. So I'm going to do this by hand first. How many of these guys are ready to graph by hand? Just one again. Which one?
The first one.
The top one, because
It's in y equals mx plus b form.
it's in mx plus b form. It's ready to graph. Let's just graph it to start out. So we'll go over here. Graph it. I'll try to be decently precise. So I'm going to go and make some marks. Try to keep them equally spaced. Alright, so x minus 6, I start down at negative 6, right? So 1, 2, 3, 4, 5, 6. Right here's a point on that line. And the slope right here says to go where? Up 1 over 1, because it's 1 over 1. So up 1 over 1 is about like that. So there's my tenuously drawn line. If you use graph paper and a ruler, it would be much, much better. Yeah. Okay. So the other one's not ready to graph because what exactly is wrong with it? It's not in that form. So how do we get it in that form? Solve for y. So we need to move what first? What could I move in this guy first?
Minus 2y.
You could go minus 2y, that's fine, but I want to move stuff in general away from y.
2/3.
So I think let's move this guy first. Yeah, let's subtract that guy first. So I'm going to do this and say, all right, so I've got 2y. I'm going to subtract this to the other side. There's a minus 2 over there as well, right? If you want to go minus 2/3 x, minus 2/3 x, do that. That starts to make your work cluttered as you get higher. And then I need to, of course, divide by 2, right? So I'm going to divide by 2. So I'm going to get, let's see what's left. Y, and you know what? Let's do this, we'll graph this line in red. So I'm going to go y equals, what's 2/3 divided by 2? Use common sense on that one. If you have 2/3 and you cut it in half, you get 1/3. There's a lot of different ways to handle fractions, and you've got to be flexible. One of the best ways is common sense.
Yeah, would it be negative 1/3?
And yes, it's negative 1/3 because that was negative. Yeah, negative divided by positives, negative, right? It doesn't change. And then 2 divided by 2 is easy. It's just 1. Okay, so this line is going to look like a y-intercept at negative 1, and the slope says down 1 and over 3, yeah, so we'll go down 1 and over 3, something about right there. See if I can draw it straight. Oh God. I'm not trusting this line. So the solution to this system looks like it might be, let's see, 1, 2, 3, 4, 5-ish. Yeah, 5-ish, and 1, 2, 3, like 5, negative 3, something like that. So I'm guessing that this is going to be 5, negative 3. So at least we should be close to that when we confirm it on our calculator. So let's confirm it on our calculator. Make sure you have that and follow along with me. The whole point of us having calculators this year is so that I can go quickly with you in Algebra 2 and I don't have to stop and slow down and stuff like that. That really handicaps that whole class. So, where are we going to go first in our calculator, guys? You want to graph this? Y equals, yep, top left. I've already got some lines in there, but they're not the right ones. Those are the ones from yesterday. So let's see, we just got to put in x minus 6 for the first one. That's pretty easy. And the second one, we've got a fraction. I'm going to wrap it in parentheses because that's one way to handle fractions. Can somebody remind me, what's the other way to handle fractions that I actually prefer? Alpha y equals is the other way if you have a newer calculator. So yeah, that's my preference, but we don't all have that one. So. All right. So there we go, and we should press zoom 6. Good habit to have. All right, there's our blue line, there's our red line. Let's check out if I was correct in guessing 5, -3. I'm probably not correct. Hopefully close. How do I check and actually have the calculator compute this? Second calculate. I wonder how it does this. And it is 5, the intersection's what we're looking for. And I like to get kind of close on the left, kind of close on the right-hand side, something like that, and then get as close as I can. And you can see that I really didn't guess very well. I mean, it looks right, but that's a totally different answer than this, right? So this answer is 3.75 -2.25. Now, I just want to also remind you of something else. Sometimes if you have a rational answer like that, something that's not forever, going forever, you might want to change it into a fraction. It might be in the back of the book like that, or for any other reason, you should just know how to change these into fractions. So does anybody know what these are in fractions?
Fourths.
So there's 3/4 here, right? So what's 3 3/4? 3 3/4, you're counting by fourths. This is the common sense way to do it. So how many fourths fit into 3 pizzas if you cut them into fourths? 12 fourths, and then you've got 3 more fourths, so how many fourths is that?
15.
It's 15 fourths. See, that's the best way to do stuff. It's helpful in trig and all kinds of places. So that means this is 2 pizzas full of fourths, which is 8 of them, and then 1 more, so that's 9 of them, and these pizzas make you sick, so they're negative. How to have your calculator do that is also kind of nice to know. Let's go back out to the home screen and have it do that for us. So just to remind you, you can go 3.75. How can you use your calculator to turn that into a fraction for you? Math. Oh, it's the very first option, right? There you go. So remember, you have that available to help yourself with fractions. Okay? So there's one example. Let's look at an application now. Alright, so here's an application of where you might need this kind of thing. Alright, so I envision that some new video services are going to be available pretty soon. Tinseltown, Cinemark, that company, other companies like Regal Theaters might be very scared of something like this happening. What I'm envisioning is that new movies become consumable right away. So like they don't release the new Star Wars movie and you have to go to the theater to see it. You can just watch it on Netflix. That would, of course, only work if it cost a decent amount of money. Does that make sense? So let's say Amazon Prime and Netflix both open access to this kind of service to compete with people who are pirating movies in Mexico and China and so forth. Yeah. So Amazon Prime, if you want to have this available to you, where you don't have to go to the movie theater to watch a new movie, you can just watch it immediately. Says, well, we'll charge you $100 per year for this service, and then every time you watch a movie, it's $4 to watch that movie. Okay? Netflix, competing with Amazon, says, you know what? $4 is a lot to charge every time, so we'll just charge you $2 every time, but you have to pay a bigger flat fee. And the question, there's a lot of questions we could ask, like which one would you want to choose? A most basic question with systems of equations would be, how many rentals is it going to be so that these two services cost the same for you? Okay? So let's do that first, and then we'll talk about some other questions that we might be able to read off the graph as well. So first we need to set up the system of equations. That's pretty basic. So can you guys help me? How many equations are we going to have here? 2, because why?
Netflix and Amazon Prime.
Netflix and Amazon Prime. There might be more services. So this might be a system of actually like 3 or 4 equations. You think those happen? Yeah. Computers solve systems of thousands of equations at the same time commonly. In Algebra 2, we'll learn out systems of 3, 4, 5 equations at the same time. Okay, but we're going to stick with 2 for now. Maybe we'll do 3 another day this year. So let's see. So I'm going to do the system bracket dude that says I want to do these 2 equations, these 2 services simultaneously, right? We should also define our variables first. Young mathematics students tend to skip this step. If you skip this step in like an AP Stats class or something like that, it will make problems much more difficult. So I envision trying to not skip this step. Define what you're talking about first. We're going to have X and Y in here, okay? You can call them whatever you want, but let's stay with x and y to make it simple. But you need to say what x and y are. What is x? What is y? Yeah, x is like the number of rentals. Isn't that what's going to be changing? That's the variable quantity. And what's y going to represent? Yeah, good. The costs for each service. So it's going to be like the money. Even if you have just that much, that is so helpful. Right now, it might not be necessary. A lot of you guys can do this without writing those down right now, I know. But if you get in this habit, when you come upon much more complex situations later, when you're taking your ACT, for instance, because AP Stats is the best ACT booster class, in my opinion, it'll really help you, okay? So, try to decide what your variables are. Write them down. So X, we'll say, is the number of movie rentals. You guys said Y was going to be the costs. Like total costs, just the rental cost. A fee cost, what? Yeah, I think you guys have some good instincts here. I think total cost sounds like a good idea, okay? Now you might not need that for this problem, but we're going to do it anyway. All right, so let's try to write these in Y equals mx plus b form right away. And we really just want the total cost, so I think that makes sense. So for Amazon Prime, this is going to be the Amazon Prime equation. What are we going to have? How about this? No,
because
why?
You're not multiplying. 100 is the cost, the flat, and you would multiply the x by the 4 because
It's a
that's your
flat
rental
cost. It's fixed, right? It doesn't change. It's constant. This changes based on how many times you download a new movie. So X could be you only did 2 movies for the year. That's not very wise, is it? Then you're paying a lot of money to do this. It could be like 12 movies a year, though, or something like that. Then maybe it starts to work out. I mean, it does cost like $10 to go to the movie theater anymore, doesn't it? If you go on Friday night or something, it's crazy. And that's in Pueblo and Denver. It costs like up to $20 if you go to like IMAX, right? If you want to watch older ones,
Yeah, that's a it's for the ones that. Just
So, anyway, so what about for the Netflix service? We're gonna have y equals
2x plus 200.
2x plus 200. Does it really matter which order you write the x and stuff on? No, but it does matter what x is attached to, right? Because this is the thing that's variable. This is not variable. You pay $200 one time, that's it. Okay? Now we can graph these. Let's just do a sketch of this graph, and then we'll have our calculator do it for us, okay? Because I'm guessing this is going to be really hard to do by hand. No one would really do these by hand. And I'm guessing on Park this year, if they have you do systems, which they definitely will, you'll have your calculator on most of those parts. We'll see, though. 100 plus 4x means I should start where? At 100 up here. So let's just say that's 100 point. So if that's 100 and this is 100, then going up by 4 over 1 is going to be kind of hard to draw, isn't it? So we're going to have to mess around with the window on our calculator. But it's going to be something like, let's say that's not 100, let's say that's 10. So then that's 5. But up 4 and over 1, if this is 1, then it's going to be something like this, right? So this is a hard one to draw. But something like that. This guy, where are we supposed to start with our y-intercept? 200, so let's try to keep this even, so I'll go that much more. So that much more is about like right up here at 200. And is the slope steeper or shallower?
Steep. No, shallower.
Both 2 and 4 are pretty steep, but which one's steeper?
The 4.
The 4 is steeper. That grows faster, right? Up 4 over 1 is more than up 2 over 1. So again, it's going to be kind of hard to draw this up 2 over 1, but this one's supposed to be shallower. So if I do this one, I'm going to have to remember, hey, it's shallower. See, this is where steepness matters, not just the slope exactly like the numbers. So this guy's supposed to be shallower. So I know that it's going to be something like this. So some systems of equations have no solution. We're going to look at those probably starting tomorrow. Do you think this one has a solution? Yeah, because these lines are not parallel, are they? They have different slopes. That means they have to have a solution. Where's it going to be, kind of? It's going to be kind of up here. And the reason we know for sure is this one's not quite as steep as that one. So eventually, they're going to cross. So we'll use our calculator to find that in a second. Let's use some common sense though here. Which service was the red service? I could label it, right? This one was the Netflix one, and the blue one was Amazon. So, whatever this crossing spot is, up until that crossing spot, which one's the better deal? Amazon, because it costs less, right? Its Y values are smaller. After this spot, which one's the better deal? Yeah, Netflix is. That should make sense intuitively because like Netflix, you're spending a lot to begin with, but you don't pay much for each one. So what kind of person, what kind of consumer would be best off choosing the Netflix option?
Someone who watches a lot.
Someone who wants to watch every new movie that comes out, right? Someone who just wants to see the 8 new superhero movies for the year, the Amazon one's a better deal. And for them, in fact, if you do 8, if you put 8 in here, how much is it going to cost them? Let's think. Plug it in there. 8 times 4 is 32 plus 100. So that's $132 they're spending to watch those 8 superhero movies. $132 divided by 8 is what? Can you guys use your calculator and tell me? $16.50. So at the current price of movies at theaters around here, is that a good decision for them, or should they just go to the theater?
Well, it depends on where you go, but
Unless they're a couch potato and really like staying at home. I like going to the theater. I don't care.
And they like stay home. And they won't go to work to get money to go see the movies.
That's true.
It's a vicious cycle.
Yeah, true. Okay, so let's find this spot where they actually equal each other. I'm guessing it's going to be hard. It looks like about 10 on my terrible, terrible graph. I really don't trust my graph on this one. Let's find it. So going to our calculator. Let's have it do the dirty work for us. So 100 plus 4x and 2x plus 200. Zoom 6, I'm guessing Zoom 6 is not going to work. It's graphing, it's graphing. Oh, it says it's done. The loading bar is done. Why don't I see anything, people?
It's too basic. You have to zoom out.
I should zoom out. Now, zoom out's the primitive way to go. That might not be enough. Let's try it, though. Might be good enough. You tried it?
Yeah.
Didn't work? So zooming out once. Oh, there I can see part of one of them. I'm going to zoom out again. I can see most of that one now. We're starting to get there. I'm going to zoom out again. There we go. You know, actually, you kind of can see it here, can't you?
Yeah.
So I think this kind of worked. A much better option would be to use what we've got down here and try to do the window manually. So let's try to do the window manually. It's really good to play around with this. Makes you a much better student. So I'm going to go and say, you know, I'm just going to start at 0 because I don't care about negative land in x. I know the answer is not going to be over here, right? I know it's going to be somewhere over here. Maybe instead of 10, let's go out to 20 at least. We'll try that. So I'm going to only go out to 20 in the x direction. I'll go by ones, that's fine. And y minimum, do I need to be all the way down, like way down here? No, let's start at 0. And our graph needs to at least go up to 200, but we can clearly see it's higher than that. So 400, or we could just leave it, you know. I mean, it's up to you. Let's try that. Wow, that's really too far, isn't it? And I didn't go far enough out in the x direction, so it's just learning to do this. So I'm going to go out 40. And I think we were going pretty high. Let's go with what Colton said and go 400. That's looking pretty good. Ah, it's almost at 40, isn't it? 50. It looks like it's somewhere around 50. I'm going to go a little bit more just to make this easier to see. But this process that I'm walking you through right here, that's a problem-solving process. I can't download it into your brain. You've got to try it. You know, it's an experimentation thing. That's how you grow and learn this. And now I can really see clearly that it's somewhere around 50 or 60. So I'm going to do what we've done before and calculate it. So you you've got to experiment with this. So I highly encourage you on your assignment to play with the window. I think I've said that about 4 times this year now. I hate being a broken record. But I will in this class only. It is exactly 50. Crazy. I didn't expect it to come out exact. So it looks like these services cost the same when you rent 50 movies, and how much is the cost at that point? $300. 50 movies is a lot. So it's pretty crazy. I think you should go with which service then? Amazon. Amazon's definitely the better service in this case.